Welcome to the second lecture of Introduction to MATLAB. So, today we'll start with the introduction to arithmetic operators. Arithmetic operators would be very helpful throughout our course as they would be the basic of each and every operations. Few of the arithmetic operations are addition, subtraction, division, exponential, and multiplication. Let's see one example of each. For example, let us first consider addition operator. 2 plus 5. The answer is 7. So you see that by using the plus sign, we add two numbers. Let's now see subtraction. 5 minus 3. Hitting enter, we see that 5 minus 3 gives 2. This is the subtraction symbol or subtraction operator. Let's see division. 10 divide 2. We use division in MATLAB or Octave, like as I have shown here. Now we'll see about multiplication. 10 into 3 gives 30. The asterisk symbol here acts as a multiplication operator. We will see exponential. 4 to the power 3. The answer would be 64. And this is the exponential operator. So these are the basic arithmetic operators that we would frequently encounter throughout the course. So never forget about them. And yes, if you wish to know about the introductory part of the MATLAB, do watch the first video. Now let's see an example which would be very crucial for understanding of how this operator works under the hierarchy. Example 4 plus 5 into 3. On hitting enter, you see that you get 19 as an answer. First, the multiplication is done, and that is 5 into 3, that is 15, and then the addition. So 15 plus 4, 19. Now, if we slightly change the expression to 4 plus 5 into 3, on hitting enter, you see that you get 27 as your answer. Why is the difference between these two? It's because of the presence of parentheses. The arithmetic operators in MATLAB or Octave have certain rules to follow. They work under a hierarchy. That means when multiple arithmetic operators are present within an expression, those with higher order of hierarchy would be solved first and then the later. In MATLAB and Octave, it follows Pemdas Rule, P-E-M-D-A-S. P stands for parentheses. Anything within parentheses is solved first. Then the exponential. After solving parentheses, we see that wherever an exponential operator would be present, it would be solved. Then M and D. Usually multiplication and division holds the same position in the hierarchy order. So if both of them are present within an expression, that on the left would be solved first, and then it proceeds to the right. And then you see A and S. A stands for addition and S for subtraction, and that would be the last in the hierarchy order. So try out any arbitrary expression that you would like, and then taking a pen and a paper, solve it using PEMDAS on a paper, and then solve the same in Octave. For example, let's take 4 plus 5 to the power 3 and then subtract 4 from it. On hitting enter, you see that the answer is 725. And how is it? You would see that first the inner parentheses are solved. Then the exponential operator is solved. That is 4 plus 5 gives 9, and then the exponential. The inner parenthesis is solved with exponential, and then you subtract it by 4 and you get 729 as your answer. Solve it using a calculator, using the rule Pemdas, and you'll be surprised to see that they both gives same answer. Now we'll talk about relational expressions that are greater than, less than, greater than equal to, less than equal to. Then you would see equal to, and then not equal to. Let's see it by an example. 4 greater than 3. Hitting enter, you see that you get an answer 1. Why is it so? Here, the 1 is a logical output. How you can say it is a logical output? See it in the workspace. You get A and S, and the class is logical and the value is 1. 1 means true and 0 means false in MATLAB. Now you'd see 2 greater than 3 and the answer is 0. As I have told, 0 means false and 1 means true. When you see 4 less than 5, it would be true, so 1. Now you'll be seeing greater than equal to, so 4 greater than equal to 4, you'd see 1. That is because 4 greater than equal to 4 is true, because we have included the equal to sign, and 4 equal to 4 is true. You'd see 5 less than equal to 7, it would be true, just because 7 is greater than 5, so the answer is true. Now we'll check whether two numbers that we have entered are same or not. So A equal to 5, B equal to 6. Still wondering why we use semicolon? I have mentioned it already in the first video, so don't forget to watch it. A equal to B, and the answer is 0. It's just because 5 is not equal to 6, and so the answer is false. You can check what type of output you are getting by simple inbuilt function named class A and S. Hitting enter, you see the type of answer we got here is logical. So you can even type A not equal to B by A not equal to B. For not equal to, first you would have to type in tilde and then equal to. It would mean A not equal to B, and on hitting enter you see the answer would be 1, just because 5 is not equal to 6, and that is true. Now we would have seen ASCII a lot of time. ASCII. ASCII is a numbering sequence of different symbols, alphabets, and digits. So for an example, you would like to know what number, symbol, or alphabet has been assigned to ASCII numbers 97. So you can check it out easily using character function, and that is inbuilt char 97, and then hit enter. You'd see the answer is A, and that means in ASCII the 97 number has been assigned to A. You can also check the output of character 97, and that is by class ANS, and you would see that A is a character. Now you would probably try it once again. Character 105, for example. We see that we return I, and so we get to know that 105 has been identified as an ASCII number for character I. You may sometime Try the other way around. You might know an alphabet and you want to know the ASCII number. You can do it easily by typing double and single quoted A. Hitting enter, you see the answer is 97. The single quote that we have entered is because we want Octave to know that A is a character in our case. So anything inside a single quote, that would mean a character or a string. And so we get 97 as an answer. So that is all about ASCII. Now that might be a fair amount of chance that you would need some of the inbuilt functions to be used. But how you can know where are the functions? In Octave, it has been made simple by the documentation section. You can click on it, go to function index and type any function you want. But for our case, we'll be using limited amount of built-in functions because all would not be that useful for us, but few may be of significant importance. For example, we use sign to know the sign of the number that has been obtained. For example, take A equal to 6, B equal to -7, and C equal to A plus B. On hitting enter, you see that C is equal to -1. But there might be a chance where you won't see an output, but you want to know its sign, whether it is negative, positive, or it is 0. So we can do it simply by typing in sign C, because C stores -1, and hitting enter, you see the answer is -1. And why is it so? The sign has 3 written values. It may be -1, 1, or 0. 1 in a case where the sign of a number is positive or the number is positive. -1 in the case where number is negative. 0 when the input variable stores 0. For example, D equal to 0, and we want to know the sign of D, so it is 0. And for example, E is equal to 100, we want to know the sign of E, and it would be 1, and that would mean a positive number. This would mean 0, and that would mean a negative number. Then if you want to find a remainder of a division problem, and like we have seen, like 11 divided by 3 would give a fraction or a decimal value number, but in many cases we need to know the remainder of a expression like 11 by 3. So we can do that by using rem, remainder, and then entering first the dividend and then the divisor. Hitting enter, you see that we get 2 as a remainder of 11 by 3. But remainder operation or the rem inbuilt function is not compatible while you use the dividend as a negative number. So there is a special different function, and the function is an inbuilt function. So you can simply type in mod 11 by 3 and you get the same remainder as an output, and it's 2. But when you use rem -1 divide 2, you'd see that you return -1, but as you always know that remainder cannot be a negative number, so mod -1 comma 2, and you would get 1 as an answer. And so we generally use mod for finding the remainder of a division problem, and we do not prefer using rem. Then you could see that there might be a case where you would need to know the magnitude of a number, and the number could be d equal to -100, but as we know, a magnitude is always a positive number or a non-negative number. So abs is an inbuilt MATLAB function that would turn all the input into a positive number or a non-negative number. So if d equal to 0, abs of d would result 0. If d is a positive number, then abs would not have any effect on the value of a number, but if the input variable, or d in our case, is negative, then abs would change the sign and not the magnitude. Now, the last part of our video, we'll talk about constants. What is a constant? A constant is an inbuilt value for a variable. For an example, if we type pi and click enter, we see that value of pi stored in Octave is 3.1416. If you type in I and hit enter, you see it's the complex I that we always use during a complex number calculation. Same goes with j. J is also considered as I, and as we know that I is root of -1, then INF is infinity. If the answer is too big to be stored, then it is represented by INF, and if your output is undefined, then it would show NaN, that is number not defined. And I'm sorry, NaN, that is NaN. NaN means number not defined, and it would be of the form 0 by 0. So this much for today. In the next lecture, we will learn how to create a matrix and how to manipulate the matrix, like how we would plus, minus, divide and multiply the matrices. And it's quite different from the numbers that we have been using till now. So to learn about matrices and different MATLAB concepts, stay tuned and subscribe to our channel. So till then, keep learning, be safe.